Okay, this set of notes is on multiplying binomials. So to start off, we're going to find out what a binomial is here. So this first term, so a name or a term, is actually the root of our word binomial, just the nominal part. So nominal means name or term. An expression that consists of two terms, those are our binomials. So if the expression has just two terms in it, we call it a binomial. And an expression that has many terms, the prefix that we add to the front is poly. There's another prefix that sometimes uses trinomial if there are three terms, and those are kind of the common ones. You can keep going if it's a four-term expression. It can be a quadrinomial. But typically, after we get past a trinomial, we usually just end up using the term polynomial. But polynomial just means that it's many terms. It can really mean anything more than one or two. So, using the FOIL method, so to multiply two binomials together, we use the FOIL method. And FOIL is an acronym, which is what ultimately it ends up being like is doing the distributive property. Property twice. And now FOIL, it stands for something, and so the F in FOIL stands for first, in which case we're going to be multiplying the two first terms in each of the binomials together. Then O is for outer. So the outer two terms get multiplied together. I is for inner. So the two inside terms, we multiply those. And then L is for last, meaning the last two terms in each. And so this is just kind of a little acronym that helps you remember which terms you should multiply together, and kind of gives you an order for doing that. But again, this is like double distributive property is what it's basically like doing. So you'll notice that down here with my two binomials, so 3x plus 5 is a binomial, 2x plus 3 is a binomial. And so we're multiplying those two things together. They're both in parentheses next to each other, so that's going to tell me to use multiplication. And so the FOIL method that we're going to use, again, we're going to multiply. So just like before where we drew the arrows for distributive property, we're going to show that here. So 3x times 2x would be our first set of multiplication, and that's our first terms. Then we multiply the outer terms together, and that's those two, so 3x and 3. Then our inner two terms get multiplied together, so that would be the 5 and the 2x. And then finally, the last term in each set, which is the 5 and the 3. So what we end up getting is we get a set of arrows from each. So 2 arrows from the 3x, 2 arrows from the 5, and then each of these terms in this one has 2 arrows going to it. But again, each of those show multiplication. So then we're going to combine, after we do the multiplication, the remaining like terms to get a simplified answer. So this is why yesterday I had you practice with distributive property and combining of like terms again, because that's basically the idea of how we're going to multiply these together here. Okay, so multiply the following binomials together. So in the first example, again, I'm going to multiply the 2x times the 3x, and then the 2x times the 5. Okay, so when I show it, a little slightly different than how I labeled it up here. When I show it the arrows, I'm going to do 2 arrows from the 2x, and I'm going to have those go on the top. And then the 1 is going to multiply to each of these terms as well, and I'm going to show those 2 arrows on the bottom. So an arrow going from the 2x to the 3x, and from the 2x to the negative 5, 1 to 3x, and the 1 to the negative 5. And so those are my basically 4 sets of multiplication I have to do, but if you analyze it, it's using FOIL. It's the first, the outer, the inner, the last. So multiplying in that order, 2x times 3x, and you really don't have to multiply in that order of first, outer, inner, last. You can multiply in any order, but it just kind of helps you remember which ones you've done. So the first two terms, 2x and 3x, if I multiply those, remember the 2 times the 3 is going to make 6. And then hopefully yesterday, when you practiced, you remembered multiplying x times x is going to cause it to become x squared. Remember when we did properties of exponents, and if you had something like x to the first times x to the first, it's going to add the exponents together, and that's why we're going to end up with x squared, because 1 plus 1 is going to make 2 there. So multiplying 2x times 3x is going to give us 6x squared. Then the 2x times the negative 5, that's going to make negative 10x. Then the 1 times the 3x is going to make 3x, and it'll be positive because both of those were, so plus in between there. And then a positive 1 times the negative 5 makes this minus 5 here. So this is what I end up with after I use FOIL to multiply this. And now I look for any like terms. Typically what the case is assuming the binomial is set up this way where there's a variable term and then a constant, and a variable term and a constant in each one, those like terms are going to show up here in the middle. Not necessarily has to be the case, but you just want to check through and see if you have any like terms. So in this case, the x terms are my like terms. Remember, the x squared term is not a like term with those. You have to have the same variable and exponent in order to be a like term. So only the negative 10x and the 3x can go together here. But we're going to get 6x squared minus 7x then, and then the minus 5 adds to the end. And then this is fully simplified. I can't combine anything else. So we end up getting a trinomial after doing this, and that's usually the case with these, is that you end up with that. So I have 3 terms in this one. Could also be called a polynomial, is fine as well. But that's how we use FOIL. Okay, practice that again over here with number 2. So again, the x term in the front, going to draw an arrow from that to the first x there, and then the negative 6, from the negative 3 to the negative, or to the x, and from the negative 3 to the negative 6. And then I'm going to follow each arrow for my multiplication. FOIL says first, so x times x is x squared. Then outer, x times negative 6 is negative 6x. Inner, negative 3 times x is negative 3x. And last, negative 3 times negative 6 is positive 18. Okay. Now I look for like terms, and once again, I have a pair of x terms here in the middle. So I get x squared minus 9x plus 18, and that's my simplified answer. Okay. If you're filling out these notes and going along with it, feel free to jump over and answer the column questions. Maybe pause the video real quick and do that. I'm going to put the answers to the column questions up in the completed version when I post that. But for now, with the video, I'm going to continue on to the next examples. So these next examples, it says write an expression to represent the area of each shape. And so in this one, my side lengths are given with expressions. And so remember, for area of a rectangle here, we need to do length times width. If I call this side the length and this side the width, multiplying those two together, they're not just whole numbers, so I'm going to end up with an expression here, but it'll be the 2x minus 9 times the x plus 5. Okay, and so now multiplying those together, notice I got my set of binomials here, which is why we're practicing this here with this set of notes. So draw my arrows. Now I'll start the multiplication. So a is going to be equal to 2x times x, which is going to make 2x squared. 2x times 5, that's going to make positive 10x. Negative 9 times x is negative 9x. And negative 9 times 5 is negative 45. Once again, like terms here in the middle with the x terms. 10x minus 9x leaves me with 1x or just x, so I could either just write 1x here or just leave it as plus x, and then minus 45 on the end. So this is an expression that represents the area of a rectangle. For a triangle, remember for these we have to do base times height divided by 2 for area. So if I call this the base and this the height of this triangle, then the area would be equal to p plus 1 times 2p minus 6, all divided by 2. And so now using FOIL to multiply that out, on the top, p times 2p and p times negative 6, 1 times 2p and 1 times negative 6. That's going to give us 2p squared minus 6p plus 2p minus 6, and then still all divided by 2. I have my like terms here in the middle to combine. So I get 2p squared minus 4p minus 6, all divided by 2. And what I can then do is I can divide each term by 2. So I can cut this whole thing in half. They're all even numbers, so that works out nicely. But I can simplify that by dividing each term by 2. So I would end up with just p squared, or 1p squared, when I divide that by 2. Here I would get negative 2p and minus 3. And that would be my expression. Okay, again, conclusions. If you're working on your own on the notes, feel free to go through those and then check your answers later with the answers that I post. But we'll jump down to the summary part of things here. So a binomial is an expression that consists of 2 terms. When multiplying the 2 binomials together, use the FOIL method, which is like double distributing. After you distribute each term, combine like terms that remain to get the simplified expression. Okay, and then a little 1 to 5 scale there for your understanding of multiplying with binomials. How confident are you feeling with that? Hopefully confident enough to go attempt some of the worksheet problems. Okay, so be on the lookout for the answer key for that coming up later in the day. But do your best. This is what the quiz is going to be on this week. Tomorrow on Wednesday, the 10 o'clock, we're doing the Google Meet. So if you have questions about it, come see me there. I'll be going over last week's quiz on that Google Meet. So if you needed to make corrections or you struggled with that, that'd be a good time to check in and get some help with that. Okay, good luck.